Hi, my name is Angelina Filius. I am a student in MSc 335 at the University of Michigan. Me and my group decided to evaluate 1,4-dioxane in Ann Arbor. We think this is a really prevalent issue that needs to be addressed. This is a quick breakdown of the problem itself. 1,4-dioxane is a colorless and odorless chemical and has many linked health concerns, including kidney and liver failure. It is also classified as a probable carcinogen. What makes 1,4-dioxane so dangerous is that it is highly soluble in water and it is not naturally biodegradable. That means once it enters a water source, it will continue to spread and not break down. 1,4-dioxane was released into Ann Arbor groundwater starting in the 1960s and has only continued to spread since then. Me and my group created a simulation in Microsoft Colab to help visualize the spread of the 1,4-dioxane plume. The X shows where the plume originated from Gelman Sciences, and over the course of 50 years, the 1,4-dioxane plume has completely covered all of Ann Arbor. This problem is a competition between transport and reaction. The plume spreads through groundwater due to advection and dispersion. To remove the contaminant, we rely on two main mechanisms. The first is oxidation, which is a fast removal process that can rapidly break down dioxane, but it's usually limited to a small treatment zone, usually near the source. The second mechanism is biodegradation, which uses specific microbes to break down 1,4-dioxane. This process is a bit slower, but it can act over a much larger region. So our goal and our key idea for remediation to be effective is having the reaction rates from these two processes be fast enough to compete with or exceed the rate at which the plume is spreading through Ann Arbor. Me and my group also created a one-dimensional advection dispersion reaction model in Colab to help visualize how the dioxane concentration will change over time if these two solutions are implemented. Our applet also includes various adjustable parameters, and users are able to change these sliders to see how altering them affects how the dioxane concentration changes. We recommend that a hybrid remediation strategy is implemented to effectively control the spread of the dioxane plume. This would mean having strong oxidation near the source and also implementing biodegradation downstream to take into consideration how the plume spreads. Our goal would be to reduce concentrations below the safety limit of 7.2 parts per billion. Overall, successful remediation depends on designing a system where our two solution reactions can consistently stay ahead of the transport of the dioxane plume. This is an issue that affects us all. It threatens our drinking water and our safety, and we hope that this is something that can be properly addressed.